Okay, so the first thing I like to test if my recliner is not working is the power supply. In this scenario here, I said that the power recliner here has a green light on it. But like I mentioned, just because it has a green light doesn't mean it's always supplying the full power. This needs to provide about 28 to 29 volts on it. And if it is not providing that, it's not going to be sufficient power to fully operate your recliner. One of the symptoms of that is it's intermittent. If sometimes it works, sometimes it doesn't. That could be a case of it. Another case could be if it all of a sudden is just working and everything dies. Usually I want to check the power supply as well. So one of the biggest things in the power supply that I always want to check is I'm going to come to the back of the chair. I'm just going to unplug this. This is just a 2-pin connection here. So if it's clamped here, all you do is unclamp it and then this will slide right out. But what happens usually is on a power supply, most common things is a dog or a cat or something ate it, chewed it up. Obviously, if this is chewed up and it's got any kind of short in it, definitely don't use it. You could short out your other components in the chair. It's going to cost you a lot more money. So you don't want to use it in that case. The other thing is it gets kinked. If it gets stuck inside the chair, it gets kinked at all, it's going to break. Or if it gets stuck in a vacuum cleaner, something like that, it's going to not be working as well. And of course, a lot of times they just get lost when you move or transition a chair or whatever it is and you can't find it, but that's what it is. But let's just say that we think our power supply might be the issue, even though it's showing me a green light here. I'm going to show you how to test this with the voltmeter. Now, I realize everybody doesn't have a voltmeter, but if you do, or know somebody that does, you can borrow one really quick and we can test this. I'm going to show you how this works. So what happens on this is to test this, you can kind of look at the power supply on this one. We can show you a picture on the screen, but the power supply of this one should be providing 29 volts. So we need to go ahead and test this and see what it is and what it's supplying. So first thing you want to do on your voltmeter, every voltmeter is a little bit different, but we're going to test for DC voltage. So the little V with the big line on top and the 3 dots underneath is DC voltage. And you can see in here we have 2 prongs. So if you can kind of watch in here, I'll try and do it together so you can see close here what this is. We're going to just try and measure some voltage here. So it is plugged in. We are going to plug in one cable in here and one cable in here, and we're going to try and measure this. If we get them both in, you'll see that we're actually working. So once I make a decent connection here, kind of got to poke those guys in there. There we go. So if you see that, I got it plugged in right there. We're pulling 29.8 volts. So, you know, you got to make sure you get a good connection in there. I got them poked in there. They're finally making a connection. 29 volts. So what that means is this power supply is good. What I'll do then is I'm going to visually inspect the whole power supply here just to make sure I don't see any kinks. I don't see any shorts. I mean, you have normal just full bends. That's kind of how the cable comes, and that's okay. But I want to make sure I don't have any shorts or kinks, and that's all there. That's important, and definitely one thing I want to see. Maybe while we're talking about power supply, I'm going to talk about one other quick thing. We talk about, in this power supply, we have a quick release is what we call, and then on this other side, we have this clamp. A lot of folks ask, well, should I use the clamp or should I not? It's up to you, really. Most of the time, these connections are going to stay in here pretty tight. You know, you shouldn't be pulling on them anyway. They should be loose. But a lot of times, we say don't put the clamp on. And the reason why we don't put the clamp on is because what we find is like, so this is the base motor and this is what it looks like, and this is how this connects right here. But when I clamp this in like this, what we find is that if somebody rips it or somebody trips on it or somebody kicks it, it rips it out. If it rips this whole cable out of the motor, unfortunately, you got to replace your whole motor. And this is the most expensive piece in this chair. So if it's not and somebody kicks it, it's just going to do that, right? It's a lot easier to go underneath and connect it than spend quite a bit of money in buying a whole new power or a whole new motor. So it's up to you, of course, but we've kind of changed our mind on the clamp and saying, hey, we found that more people kick them out and we have to replace a motor, that it's really just not worth your money. So as long as you get them in there tight, don't pull on them, they'll stay just fine and you'll be okay. Up to you, but like I said, we replace a lot of motors that just get pulled out. So that's how you test a power supply and know if it has the right voltage.